Today, plan why guys would be we would like to uh, go for some advanced concepts of MongoDB, right? So lots of internal part, lot of core concepts of MongoDB, and it is not only the MongoDB. It is also about uh, you know other databases also. So this concept is there in other database also, but how we can deal these concepts, right? I'm talking about how you can go for aggregation framework, how you can go for increasing and improving the performance by indexing and something like this, right? So lots more concept guys we are going to discuss today in the MongoDB. So let me start directly because I believe if you have practiced what we have done in our last day one of the workshop, you guys might be comfortable with the MongoDB. But the way I started in my first day, I started the things from very zero. And I explained to you MongoDB is a database server. I explained to you MongoDB is a document oriented. Plus, I also explained to you whatever you want to perform in the MongoDB, right? CURD operations, create, read, update, and delete. You have to tell your request in a format called JSON. So what is JSON, guys? That also I discussed in my last class and other things also. So multiple things. If you guys try to collect day one, multiple different aspects of the MongoDB, how you can contact the MongoDB with API, with API. So I have taken this example also with the help of Python, but I have given the approach. So whatever language you guys know, maybe for example, if you know Node.js, you can also use Node.js. You can also use Scala or maybe Java to contact to the MongoDB. Everyone has their own different driver that will be different. For example, in Python, we have Mongo py or py Mongo library. If you go for Node.js, we have Mongo's library to do object mapping, or maybe you can think it is one of the driver from Node.js language. If you go for Scala, they have a Scala, PyScala kind of driver they have. So depend upon language to language, which language you want to interact with your MongoDB. Everybody has their own driver name, but the concept wise they are same, right? The how to use the MongoDB, the internal concept of the MongoDB is the same. Okay. So this is one thing I just want to quickly revise. Plus, we also discussed already how to connect MongoDB with the web UI. So Mongo Compass we used in our last class. If you want to connect MongoDB with the web UI, but I normally prefer CLI because this is the way we can interact with the MongoDB with their all the commands. And if you're comfortable with the commands, or I can say the MongoDB query language command, you would be conceptually clear. And if you're conceptually clear, so if you want to integrate or customize your MongoDB things, mainly the queries, you can very easily do it. So just was in one day, I don't know, have you realized or not, but just in one day, we have covered a lot. Even though I don't know if you see the agenda or not, almost all the content of the agenda, right, we had covered in the first day. Right, there might be some content left, but that we'll discuss today very quickly. But almost all the content that we have shared, guys, in the agenda, uh, just in one day we had covered everything. Plus some more extra concepts we have discussed logically in the first day. Okay, so because we have covered almost all the content on the first day, so what's the plan for today? So I'm going to go for some advanced and complex topic of the MongoDB that might be not the part of the agenda, but I told you in the first day, for me it is not like only a workshop. I try to touch multiple aspects of the MongoDB, just like normally we do in some intermediate or advanced kind of training. So think it is a kind of, not actually a kind of workshop, it is a kind of training. It's good for you. So that is the reason I make the today's second day as a spare day so that I can go mm, and touch a much more advanced concept of the MongoDB. So without wasting the time, let me move to the next day, means the last day, second day. Plan would be uh, to go some advanced topic. Okay, and that first topic is very interesting, very much useful, because this topic is more about in improving the performance. And guys, if you remember in my first day, this is the way I started my MongoDB workshop. Okay, so if you want to improve your IO performance or operations performance, how you can do it. Okay, so what I mean by IO performance, by my first demo, you guys come to know what I'm talking about. Okay, so let me start. So I have my CMD open. I'll directly jump to MongoDB. In my case, MongoDB service is running in my Windows. I hit enter. MongoDB cell started. Okay, let me clear the screen and let me show you how many databases I have. So these are the databases, guys, we had already had, or maybe we had created in our last class. Okay, so what I'm going to do for today's practical, where we talk about improving the performance, I need some data that is a big in size. Okay, or you guys know very quickly if I revise in the MongoDB, the file that you normally use in the other database world table. So here table is known as collection. Okay, every rows normally in other language is known as rows or the records. Here these are known as documents. So technically MongoDB is a collection of document, and all the collection, guys, they put in one big folder that's called database here. Okay, so these are the basic terminology that we have already discussed in our first day. So these are the databases we have. And but for today, guys, for today's demo, I need a lot of documents, a lot of records, so that we can do some test some performance and do some more advanced thing, right? So what I'm going to do, let me go exit. Okay, and I have one format. I have one work space. Okay, and I have one this file called person.json is a big in size. I think this file we had already used in our last class. This file I think has around 5,000 documents. So what I'm doing right now here, I'm in my Windows prompt. I'm not inside MongoDB. Okay, I'm inside my Windows prompt. Okay, and from here, this is a file with the JSON. What is JSON we discussed already. So we have a utility or a command, I can say MongoDB and Mongo import command, and I am taking this file, okay, and directly import inside the MongoDB. And obviously, guys, you're importing the document, so you should be very clear in which database you want to import. So I'm creating some database. What I want to create, it will be your choice. Either this is already exists or you want to create a new. So you guys know MongoDB is dynamic. If this database not exist, automatically they create for you. And inside this database, which collection you want to use, and you have to tell something about this file. So my file has a JSON array. So this command, guys, I think we had discussed in our last class. So one click, the entire database is done. So they say we have imported successfully, but no document failed to import. Why this is the challenge? Might be possibility, guys. In my case, my MongoDB uh, program is not running. So if you are using any other databases, okay, if you're using Mac OS or Linux OS, so there guys, you have to manually start MongoD command to start MongoDB. I told you in my last class. But in Windows, MongoDB work like a daemon, like a service. And if you want to start any service in Windows, there's a command called net. Then the option command called is start, and then we have to give MongoDB your daemon name or the service name. Okay, I think it's Mongo. Uh, so what is the challenge? Why they're denying? Service is actually running already. So I don't know why they are come up. Service is already there. Oh, sorry. I'm so sorry. Right. I don't know why I'm focusing this word. This is already imported. I had one thing in my mind that I have to tell this command to you. So technically, MongoDB is all running. That is the reason I have connected. That is the reason I connected. But if you guys service is not running in the Windows, so by chance this is the one of the command you can use. Or if you want to stop the MongoDB service is in Windows only, okay, you can use stop command to stop it. That is one thing. But technically, what exactly I wanted, it is there. Okay, so let me again move inside the MongoDB, or maybe let me open my new prompt, and and if I run Mongo, prompt come up very quickly. We can check. So this is the database come up, and if I go inside this database and try to see how many which collections we have, so this collection is there. And if you try to check in this current database where I am in this particular current collection, if I want to find the total record, so it will print the entire data. So find is like a read command, like select start from table kind of command if you compare with other database. And so this must record come up. Maybe if you want to probably print, you can use pretty. So they will pretty print for you. So look very clear what the output. So till here guys, nothing very fancy here, and we know everything about it. And if you try to count, so technically I have 10,000 record over here. Okay, so why 10,000? I had no idea, because maybe I imported 2 times. That is the reason is 10,000. So very quickly, let me again drop. I don't want any uh, any kind of conflict come up. Same, because I imported 2 times here. So let me again import with the same command. Okay, again 5,000 document imported because I deleted. So again, let me go inside this database and again try to find. Now, yeah, we have 5,000 record in totality. Okay, so now we have a huge data. Now we can work on this data for multiple things. Okay, so first topic that we are going to do in this particular documents to test would be indexing. Very important topic, very powerful topic. Okay, and this topic is mainly help you to improve your IO performance. So I will explain you guys this topic in very much in detail. Okay, but the topic name is guys was index, or maybe you can use the word called indexing. Okay, so what is index and what is indexing? I'll explain you in a minute. Before I explain you, okay, let me first show you some query here. Try to understand the output or try to understand this query. Okay, then we move to this topic indexing, so you can logically understand what exactly we are doing here. Okay, but by the meantime, let me do one more small thing. Let me open your document. So all this command guys I'll share to you on day 2. So MongoDB. This folder guys I believe we have already shared with you. MongoDB document. Day 1 we have shared with you. This data set is also I shared to you. Okay, So this is the command. Let me also share this command to you. Okay. Now let's move to the main part for today. Till here, you guys know we had discussed already in detail. Okay. Now what I'm going to do in this current database where I'm heading to my table. This is called collection, and I would like to find something. Okay. What do you want to find something? So guys, it is very much because right now you have a 5,000 record in totality, and every record has document has a lot of information there. So what can you do rather than you find directly something? Just there's option called find one. What they do, they will pick one random document. Okay, they will find one document to you and print this document for you. Okay, print this document for you. And find one, guys, is by default print in a pretty format. So in the find one, if you try to use pretty, it won't work, they fail. So pretty doesn't support with this function because this is a by default nature of this function to print pretty. So pretty normally work with find, where you will print multiple document. Okay, but there's one small thing. So find one is a function that will print only one record for you. Okay, now what I'm going to do here, this is the record. Okay, so technically in this current collection, right, we are storing lots of thing here. Okay, we are storing the gender information of this particular guy or particular person. Okay, we maintain the location over here, right, the coordinates, time zone, email, login. Okay, and because we have lots of information about this document, so to properly arrange, okay, what we did, we have done my document start from here, and inside the document I have one more document. And guys, I told you in my last class, this is called embedded. So one document inside other document, so we embed small or sub document in a big document. Purpose is I want to keep the entire information in one single document. Okay, that's the purpose. Rather than, guys, if you guys know, in other databases, we keep this information in other table, we keep this information in other table, and they connect all the table with the concept called join, something like this, to have a one single output. So maybe sometime that is a good way to manage the thing, organize the thing, but that also, guys, impact the performance in somehow. Okay, so here, guys, we try to put all the document, all the information about one single person or one single object or one single entity in one single document. How? With the help of nested. Again, it is not compulsory to have a nested JSON block here or nested document here or embedded document here, but it's good way to manage. If you want to only try to print the name, so we just go and say, just go in this document, only go and print the name information. Or maybe you want to print the name with the title, I can say name dot title, they will print for you. So those kind of query, guys, we had discussed already. Right now, my area of interest is about the age. Okay, so if you see here, guys, this particular user age is 29. So age is a variable or key, 29 is the value, but by chance this age is there in one internal document, and this document is been managed by a key called DOB. That's for date of birth. Okay, so if you want to print the age, I told you in my last class, you have to print, you have to use dob dot age, right, somewhere in the find, and that will help you to print. Okay, or if you have a requirement, if you want to search the age, all the age who is 29 in age, you can again do dob dot age. So let me show you again this query, but very quickly. So I'm using find because find is the one who will find everything for you. And what I'm asking the find, can you help me? We have a dob is a one key. Inside this, we have one more small key. Okay, so I want to find all the age who are 29 in age. But you guys know in the MongoDB, whatever you query right, it should be inside a curly braces because they work on JSON. So this is very simple query. If I hit enter, so you can see guys a lot of output come up, but in all the output, all the output you will find the DOB age is 29. DOB age is 29. Okay, so that's what they search for us. And if you try to count how many guys we have of 29 A's, so right now we have 97 in totality who has 29 A's. 30 age is 94. 20 age, nobody we have. 19 age, nobody we have. Maybe 25 age, someone we have. So technically I believe in this my database we have a lot of guys who age start from 21. So 21, if you keep on checking from 21 onwards, we have a lot of person over here in our data set. Okay, so pretty simple query, but why I'm taking you guys in a minute, you come to know. But if you are interested to search or to count or to print everyone who is above 25 or above 60. For example, if you see here how many guys we have above 60, so not above 60 exactly 60, this much guys 61, this much guys 65, this much guys. So rather than keep on typing in this way, obviously there's option you in programming world is called greater than, and how to use greater than you guys know. So if you don't want to put a static value and you want to do some, if you want to put some functions here or conditions here, you can add curly brace start, curly braces close, and there is a lot of function available in the MongoDB. One of these is GT greater than. Okay, and here you can tell I want to count everyone who age is greater than 60. So this kind of guys query I have discussed in my first day also. So here, so totally 1222 is the total number of document I have where age is greater than 60, or maybe you can print pretty here this particular things to check the details. So you can see here this age is 68. If you go up, their age is 71. Not the register age. I'm looking for the DOB age is 71. So pretty simple, nothing very special here. Now what I'm trying to tell you guys here is, okay, this is the query we have written. But guys, normally we use MongoDB, and I told you guys almost every top company in the world is a client of MongoDB. And these clients are big companies, they have a huge data. Okay, and because they have a huge data, so they are very much concerned about the query that you write and data that you're searching, how quickly you can search your data. Okay, because idea is pretty simple. Okay, if you're searching something in your collection, obviously your document, and if you're searching, say it take 2 hours in one searching by writing one query. Okay, so it is not a good way. So this output might be not so much relevant for most of the cases, because 2 hours, none of the client can wait, or none of my team might wait. Okay, to just wait for 2 hours to having the output. Why 2 hours? Maybe because I have billions of documents that's searching everywhere, age 60, age 60, about 60. So it might take a lot of time. Right now my data is so small, 5,000 record only, maybe in just KBs or MB of file. So, but technically in the real world, we have terabyte of data we have. Okay, so what my concern area is, we have to create some plan. We have to create some plan where if I can minimize the time of query, that's called execution time. Okay, so let's say this query might take 2 hours. How can you minimize this execution time? Before this, you should know how to analyze the query. Right now, it look very clean that this time, in this case, my query is running very quickly because only 5,000 record we have. But before we guys optimize our execution time, before we create some plan, we should have some way to analyze, so we can see the difference, that before any planning we have this much time taken, after we do some planning then my performance increase or degraded, we don't know. So technically, if you want, that's called guys concept called query analysis. So if you want to analyze your query, okay, how we can do it. So for this guys, there's one beautiful function available that you can write before the find, that is called explain and dot. So in this database, in the contact collection, whatever functions we are running, before this I'm putting explain. So they will explain my further function find or whatever find one we write right here. And what this find explain will do for me, let me print run it. So again, they will give the entire same output. But after the output, guys, not giving the output actually, but what explain give me, they tell me something about what I have find is doing for me. Okay, so one thing they told you very clear, that you ask find to go to this particular key and search for this data. So this is your query, and you ask your query planner to parse this query. This is one thing they are talking about. Second thing is they're talking about, because you ask your database, so you ask your find command to search this guy, where obviously in entire collection. Okay, so what they've done, they go to every record of the collection, guys. Now here the thing is start. So we have a record 1, document 2, document 3, document 4, this one, this one, this one, this one. So by chance, guys, this is the default nature of your find function in the MongoDB. Whatever you're searching for, they go to every record, search that do you have age about 68, 60, about 60, about 60, about 60. The search in all the document. Okay, and that is also known as, and this search is also known as scan, and because they are scanning the entire so entire collection, so this is called collection scanning. So the by default planning they use is they're doing collection scale. So this is called stage here. So the plan by default MongoDB used is the collection scanning. So I will elaborate more in a minute, but that's what they are talking about. And this is just information about my local laptop where MongoDB is. So main guys thing that I want to focus right now is this part. Okay, they are searching in entire data. Right now we have 5,000 record, that's okay. But if you have billions of record, searching everywhere might not be okay. But obviously without searching, how can we find? So point is we have to search every record, but but if you search every record, it will degrade the performance. It will increase the execution time, and we don't like execution time. Even though guys, by chance this particular output doesn't tell you what is the total execution time this query require, but in the explain function, we have some kind of internal keyword or internal function through which what can we do? They will tell something about your query. So right now, if you run here, explain command, guys, print us your query planner. Okay, so this is a by default function explain command run for you. What I mean by this, so if I so copy this line and again print inside the explain. Okay, so if you type this, if you don't type this, same output come up. So by default nature of explain command is they print query planner, means they are giving a very basic information about this find query, this information that I explained to you. But if you want to go for some detail information about this query, so there's an option, guys, here, or there's a function or keyword here. That keyword is called execution. execution states. So they will talk about your execution statistics about this query. So these information come up, but this command guys tell you your analysis of this query in more in detail. Okay, and that would be helpful for us in a minute. So if I hit enter, you can see guys that lots of information come up about this particular query. Okay, and now they print the query planner. It is a by default nature of explain command, but now they also print the execution states also. And what they give you, they tell you lots of things here. First, very interesting thing that I very much like is total document examined is 5,000, because you guys know I told you already in our current database we have in totality 5,000 documents. So technically the by default nature of the MongoDB, they will go and look in search in all the 5,000 document or maybe 1 billion document. That is the reason it is called collection scheme. So that's what guys, they're very clear here. They have done and examine all 5,000. Okay, and what are guys the query you are looking for? After they search what you're looking for, they return with 1 to 2 document. Here also they return with 1 to 2 document, guys. That's also I showed to you, even though you can just count here. So total 1 to 2, so they are almost right. 1 to 2, but my main point here to show you is this one. The total time taken by this query at this point in time is 6 milliseconds. Even though guys data is so much small, so 6 seconds is okay. But again, this 6 seconds doesn't mean it always 6 seconds. If you run the same query in your laptop, it's based upon RAM and CPU also, and based on my other process in my laptop is also running. So if I run this query again one more time, maybe this time my time will little bit change. Now they have 3 seconds to be completed. Maybe if I run one more time, again 3 seconds. So it's based upon my laptop, other process also running. Okay, but my main point here is to focus here is how we can minimize this time. Even though data is so small, 3 seconds is again very much less. Not second is millisecond, but if somehow we can minimize this time. Let's say initially they take 6 seconds. Okay, because if I run the same query, they might sometime also put in the caches. Okay, but let's say initial time is 6 seconds come up. So somehow if we can minimize this time from 6 milliseconds to less, how we can do. And what is this keyword called total key examine 0? What is the meaning of this line? So we'll discuss guys this concept in a minute. So now come to our main topic. So so what our requirement is? Our requirement is I'm looking for DOB, date of birth, age, and where age is greater than 60. This would be our requirement. And we have total 5,000 document, and I want to improve my performance, or I want to decrease my CPU time. In programming world, it's called time complexity. Here is called time execution. So I want to decrease the time execution. So obviously, lesser time take, faster output come, faster they go to client, customer, and they will be very happy that you are providing the output in very faster way. So how we can do this? Okay, so for this guys, one idea we can one interesting manipulation we can use here. But before this, you should be very much focused what actually you're looking for. Okay, do you looking for age? And if you think this is one of your criteria, and this is the very common thing you always do in this particular database or document or this collection, mostly you always search for the age greater than 60, less than 20, or more than 25. And if this is the requirement, if this is the requirement, what can you do? What can you do? First time, only once, only once, you can go to all the document, okay, all the document, and pick the age of everyone. Maybe let's say in the first document, age 26 come up, then age 78 come up, then age 35 come up, then 80 come up, then 45 come up, then 23 come up, 67 come up. So pick all the age of all the document. You guys know one thing, all the document, guys, we know with the unique ID. So if you search in the document, let's say with the find one. So guys, by default, when you create a document, every document, guys, we give a unique ID, either you give or they give you automatically, and in a variable called underscore ID. So it is unique ID of this document. Okay, so what I do, I can do one thing, because I know every document might be name same, location same, but ID is always unique. So what we'll do, we'll go and retrieve the ID and say this ID has the age 20. Okay, so let me write here, for example, ID who is 1C, for example, in last. So ID who 1C in the last has the age, 29. Maybe what next ID is 1D, have an age 127. Next ID is 1E, because they normally give the ID in the sequence, but it will be, doesn't matter, it will be anything. So this kind of we initially collect the information. Only one criteria in the mind, that mostly the query, my customer or my internal developers or my intercompany users or analytics guys, they mostly do the query only in age. And they're looking for the age. So I pick the age here and collect all the information. And then because we know we have to mostly do the query on the age, and we know age is the number here. And guys, you guys might know this concept. If you have a lot of data here, let me focus on this part only. And if this is the data you have, or let's say this is the list or arrays of values you have, and if I'm asking you, does this data has age 29 or data has age let's say 81? So nobody can say. Right now we are human being, by looking at data we can say very quickly, but for the computer they have to go and check every record, every number. So computers pick one number, 81 no, 81 no, 81 no, 81 no, 81 no. After looking for all the number, it's called traverse. After traverse all the number, then they come to know, no, we don't have any 81. So last the output come up, we have no age 81. Okay, but if you're looking for let's say 21, so again they do the same thing. They go and retrieve or examine the entire 5,000 record, and they say no, we don't have 21. Okay, but technically this means if you're searching anything, right, they have to go through they have to traverse through all the record. But if you can want to improve these things, right, technically this concept is called search. And what we are doing, actually we are doing search algorithm. We are searching something there. Right now we don't have to create the algorithm for searching. MongoDB has provided to you how, with the help of find function. So find function is like a search algorithm for you. Okay, but if you want to improve your search algorithm, that is a final goal. Okay, so for this, what can you do? Before you search, whatever data you have, if you can arrange your data in order format. Okay, for example, we know 23 is smaller, then 35 come up according to this data, then 45 come up, then 67 come up, then 80 come. If I arrange the data in order format, that is also known as sorting. If you sort your data, okay, in this order, okay, you know what benefit you get. You have to sort only for once, only for once, Now, because we know this data is sorted, okay, and now if I ask you, can you tell me, do you have anyone who is 21? Now you can see this time searching is so faster because as soon as you hit the first record and you find 23 and you know 21 is less than 23, it means there's no chances 21 age is here. Okay, so it means we can, without going to other record, without parsing or without traversing or going to all the 5,000 record, just in one single go we can say no, we don't have age 20. Something like that. Or if you ask, do you have, can you show me all the age above 45? Okay, so I can directly jump to 45 because we know it's arranged because we know about the 45, there's no 45 guys here after this. So we'll just go and count this these guys, and we can very quickly say equal to and greater than 45, we have three guys. So technically what I'm talking about, I'm talking about, if you, because you're looking for, mainly requirement is only on age, if this is the criteria, or maybe your criteria is different, criteria is different. So if we pick only the ages and arrange those edges in the order format, how, with the help of sorting algorithm, in order format, okay, in this format, what benefit you get in the future? If I ask you, show me all the age 45. Okay, because right now we are not only retrieving age, we also retrieving at the same time the unique IDs also. So let's say while they're doing sorting, we also put their ID of the record. Let's say 1E, 1F, let's say 1G, something like this. Okay, and now if you are looking for, can you show me all the age, all the record or document who age is 45 and above 45? So we can directly go here, and now I can see very easily only three records we have. It means only three record we have to examine. Plus we also know the reference, we also know the ID name. We can directly go to this ID and retrieve their document. Rather than we have to examine other document that age is less than 45, I don't have to go here. So for example, right now in our case, okay, if I'm running this query, above 60, we are looking for above 60 age. Okay, only 121 output come up, but we have to examine all 5,000 reports. Even though if I again search for above 70, for example, okay, example, we again have to examine all 5,000 record, but only 5 record match. Sorry, 5 seconds, not 5 seconds, only 300 record match that is above 70. But for above 70, it is examine everyone. But if you retrieve initially age, only age, and make store somewhere in order format, okay, and this order format, guys, you assigned with their unique numbers. That's called IDs here, because here every record is known by ID. If this uh, part, if you manage and you arrange initially, then your searching would be so quick. Now here, now if you run the same query here of about 70, what happened? Now they have to only look for this record, because we know this order number, this is below 70, this is above 70. It means we have to only examine one record. We have to not examine none of the record we have. And because now we know we have only one guy about 70, and we know the ID, because of the ID we can go and retrieve the document and present the document here. So things would be very fast. Okay, so this concept, guys, here is known as indexing. Okay, so retrieving all the ages, arranged in the sorting. Okay, and all the edges, guys, is a reference, has a reference of their respective document name. So that is known as indexing. Okay, you can think indexing in one more way. For example, you have a book, very thick book, for example, this book has 1,000 pages. Okay, every book we have a multiple different chapter, paragraph, multiple different information, definition. Okay, and if for example, let's say this is the book of artificial intelligence, and if I ask you, can you search one term there? Let's say search for the term called, let's say, MLOps. This is one of the very much popular topic nowadays in the market. Use AI or machine learning kind of concept behind the scene. So let's say I'm asking you to search to read this topic, okay, in this book, but I haven't say which page this topic is written. So one approach you can use, just go to one page, look for this document, this chapter, or this definition, page 2, page 3, page 4, page 5. It means you're looking for all the thousands of pages. Okay, means you're traversing all the 1,000 pages, and somewhere if you find, if you're lucky, then you start reading. Maybe if this is maybe 999 page number, so that much time you have to first invest in searching. When you reach there, then you can able to read. Okay, this is one of the approach, and this is the one of the worst approach I can say. Okay, but I have no other option left, because the guy who created this book, they doesn't help me in any other way of search. Maybe next time you guys can give the feedback to this book's owner or the publisher and say, your books is good, content is good, but it takes a lot of time going to our main topic and searching that topic. So next time, guys, if these guys are intelligence of the publishers, what they do, right, all the important topics here, this MLOps, okay, or maybe other, they treat this guy as a key. They pick all the keys, okay, arrange these keys. Let's say we have a one topic called machine learning, we have one topic called deep learning, we have one topic called computer vision, we have one topic called NLP, we have one topic called MLOps. Okay, so pick all the topic from the book, main topic that normally everybody looking for. Arrange this topic in the sorting order, alphabetic sorting order. Okay, and only topic name, not the content. And plus, after, yeah, before this topic, they give one more thing. They say on page number 31, paragraph number 2, on page number 37, paragraph number 5, they put this kind of mapping or reference. Okay, and this information, guys, if you see, guys, mostly in the book, in last pages, this kind of information they give to you. And now in this big thick book, if you're looking for a topic or ML ops, you don't have to go to all the thousands of pages. You just go to in some last 2 or 3, 4 pages where they create this and provide this information to you. So what you do there, you just, because they are already in sorting order, so just go to A, B, go to M and MLOps. This is the way you search, and you find, hey, I found this topic, what I'm looking for. Okay, and this is there on the page number 999. So directly get the guys a reference, the address where this topic located. Now you don't have to search in all the 1,000 pages. You know the reference address. You can directly reach to this page, go to this paragraph, and start using this document or start reading this definition. Okay, so this is the best approach, and almost all the big books, all the books use this approach. So guys, you know what they've done? They have created an index for you. And there's also, guys, they use the term called index, that this is the index we have created. So this is also indexing. Okay, so almost all the big searching engine, not searching engine, all the searching in the world, engine in the world use indexing approach. And there's one more concept called inverse indexing. For example, if you go to Google, if you search something in Google, they again use the indexing method or algorithm so that we can search. Then by chance they're known as inverse indexing, but again we are not in the Google or searching index topic. But I just want to emphasize indexing is so important because we have a huge data, huge document. I can search everywhere. If you use Google, start searching in all the, I think 800 or 900 billions web pages they have. If you start searching on all the pages while searching, so you have to wait for some days maybe or some hours to come up out with the result. But why they are super fast? Because what a document Google has, they create an index. Okay, and when you search something, they look on the index. Whenever what you are searching in the Google, they go this sorting data. Let's say you're looking for CV, they find CV, and now they come to know which website, which pages is this data have. They will provide those information to you. So they have some more complex things. So we are not in this topic, but I believe you have a high level idea. I understand high level what I'm talking about. Okay, but here we are into MongoDB. So my point, guys, here is if you are looking for the age, okay, if this is your requirement, and if you say this is the mostly my requirement to search on the age or address or the name or the books or the publishers, all right, so that particular information you can pick, sort it, and give the reference. This entire concept is known as index. Okay, and obviously, guys, if the index come up, your speed of searching will be increased like anything. So how you can create the index, that's the topic. Let me discuss here. Okay, so let me show you guys how you can create index of this topic. Okay, so for this, in this database, in this database, uh, in this particular collection, because obviously collection has a data, if I want to check how many index I already have, okay, so by some guys, we have one index already with us. Not indexes, index. No, indexes only. I think pretty doesn't work here. Okay, so how many indexes we already have? So we have only one index already with us. And so guys, when you create a collection, they automatically create the index, and they create the index based upon your underscore ID. Means they say ID is unique. So they always arrange your document in the sequence of the ID. And that easy reason, if you know somebody ID, or because they arrange the IDs in the sequence, you can directly go to this page or the sequence to retrieve document. So if you know somebody ID, retrieving those information or searching those information, obviously the find won't be the big deal. we have, if you have 1 billion record, because you know the ID, they arrange the ID already in the sequence, they directly go to this number, okay, and retrieve this document for you. So technically that easy reason, searching with the ID is so fast always, and that's benefit, guys, we are going to achieve here, right? Take here. So that is the reason, guys, we are arranging the age in the order, and we are mapping to the ID, because we know the ID is searching so fast. So if you know somebody age, and age also arranged in the sorting order, we can say, just tell me the guy who has age 67. So because my data is already arranged in ages, in sorting order of the age, so we can directly go search, do you have 67? If yes, I want to go to all the records, we can very quickly find 67 is there. We know the ID, and because ID searching so fast, because ID index is already there by default. Index means they say ID is already arranged in the ascending order. Why ascending? Because one, there's one represent, okay, that all the IDs in the document is already arranged in ascending order. If this number is -1, it means they arrange or they sorted in descending order. So this one represent ascending or descending. One is ascending, and if you have -1, that descending. But this is, guys, by default nature uh, of your Mongo. This doesn't gonna not gonna help me so much what I'm looking for. I want to create my own index. How? So for this, I can go for DB context, and there's option called create index. And here you can tell your index is based on which key. So I already explained to guys you my index is based on db.age. That's all. It means I'm asking this function go to context, retrieve all the columns, sorry, all the rows. That's called document. Retrieve all the ages, sort it, and store this information somewhere with age and ID, age and ID, because every document is known by the unique ID. But how to sort in ascending and descending order? So whatever your preference would be, because this is just a number, and if you think your mainly your ages ages mainly age smaller number are more or less, and you think you have to search more on smaller number or a bigger number, accordingly you arrange your data. So one means ascending order, minus one is descending order. Let me go forward. So technically guys, your index is created. That's all. So all the entire explanation that I have done for you, okay, is done by one single command. Now you don't have to worry much. This one single command will do the entire thing for you. Okay, and this concept is not only guys in MongoDB. Almost all the database has a concept of index. Okay, almost everyone has the indexing concept. And now if you run get indexes command, now you can see one index come up. So my index is based on key. Okay, means they retrieve this information the way I explained to you, and after retrieve they arrange sort my data with ascending order, smaller than bigger and bigger and bigger. Okay, in this way every index they give a unique name. So this is the name of my index that I have created. Something like this. So this index they have created. Now same query, if I'm running again, you don't have to do anything else. Same query I'm running again. Okay, let's say I'm looking for A6. Okay, what I want to show you guys, same query running here again, and I'm showing you the execution status here as analysis. What you will see, let me run. What you will see here, you will see a quick downfall, and the good thing, the quick downfall in the the performance of this query, even though very harder to compare, because already my execution was 6 millisecond initially, or 3 millisecond initially. You won't see big difference there because data is very small comparatively, but you'll see one big difference here. Yeah. Now last time the total document we examined was 5,000. They got 5,000 document. After they have an indexing, right? Now they only examine 1222 document. Only 122. Okay, and whichever the document guys they examine, they find the result. So it's so interesting. Means wherever I'm searching, I found this. So it is like a luck factor. Okay, it's like a luck factor. Like means we have a billions of record, and if I touch 1,000 record, where I touch, I found mass. Or something like this you achieve. It's not a small thing, guys. Okay, so anybody who know about big O notation, here, this is your best case scenario. Just in one go, wherever you hit, you find the answer. Where you search, which document you search, you find the answer. And because it is taking the help of indexing, and that easily guys here, this number come up here. Because my data is already arranged in the sorting order, and we know our criteria is more than 60, and we found here we don't have to go and search here, not here, not here, not here. We start from here because we know it is getting 60. So we search here, we search here, we search here. So obviously we only examine only those A's that is 60. So because is data is sorted, we'd actually hit this guy, we'd actually hit the document, and we'd actually examine the document and retrieve the value. and return the value. Here, this much value return. Okay. So because of the help indexing, this is so quickly done, and now we don't have to do entire collection scanning. And now if you guys see here, my stage name change, we are fetching these limited data. And here this scanning name is called IX scanning. So last time, guys, your MongoDB is so intelligent. Okay, last time they know there is no indexing, so they search entire collection. Let's go collection scanning. But now when I run this query of searching, they know index is there, so they are not doing collection scanning. They are doing IX scanning. IX here is called index scanning. And they say if you only look for this much record and this much value will come up, that's the nice thing. Nice thing. Okay, and if you see the execution time is 3 seconds or 3 millisecond. Last time is 6 seconds, but sometimes they will come 3 also. But I told you guys data is very small, so comparing time might not be come very down, but more and more and more record come up. You see exponentially, not small, exponentially, or I can say logarithmic, logarithmic in log format, your time will change drastically. Okay, it means whatever you are searching is called input operation, or maybe sometimes IO operation will change drastically. Drastically. And interesting thing is, this is the MongoDB, and the nature in the MongoDB, we store the entire document of one person in one document. Okay, so while searching, I don't have to go to this table and this table and this table, map this table, foreign key and primary key, if you guys know joins. So we don't have to go here and there. That also, guys, also it's not there in the MongoDB, so it's also improving your performance like anything. Like anything. So this is a very powerful topic. Implementing of indexing is not big deal here, but I explain the internal concept how it works. Okay, and obviously, if you want to delete indexing, so we have a function called drop index, index or indexes maybe. I say I have index name dob dot age. I will delete. I will have to give your full detail. So this particular index has been deleted. So if I search here again, get now this is the byte of index what we had. Now as soon as I delete, again I run the same query. This query is intelligent or altogether. If I run here, now they know index is not there. They are again come back to the execution stage called collection scanning, and now again they search entire 5,000 record, because I have no index key available, so nobody is going to help me. And so output same come up, right? It's not about output difference come up, but because this time again same, because data is very small. But from here you can see, because they exert more, obviously that they consume more time. This one thing. Okay, one more thing I want to show you here. If I search here, guys, it's a very important point to understand here. If I search all the age above 20, and here, guys, we see here we have 5,000 report, and everyone here, I show you in my last examples also, everyone here is above 20 age. So all the result come up here. This time 6 millisecond it took. I don't have an index here. Let me run one more time. Around 3 seconds it took. Let me run one more time. Again 3 millisecond they took. Let me run one more time, because sometimes they also maintain some caches. So guys, between 3 to 6 millisecond they are consuming. Let me on average force around millisecond this query is consumed. And I don't have an index. Okay, Now, if I create an index again, right? And why we're creating index? Because I want to minimize this time. I want to decrease this time. Okay. Now, if I run my query again, my criteria change. Again, I'm searching for age only, but now age is greater than 20. Just I change my small criteria. Otherwise, searching is the same thing. If I hit here, okay, what I'm trying to show you guys here, okay, here, if you see time increase drastically, time increase. They done index scanning. They search all the 500 code, okay, but time increased drastically. Right? Even though I have index, and index is meant for improving the performance, but in this query, I'm not saying this is the exception query, but in this query, the time increase drastically. One more, sometime, let me run one more time. So guys, they're showing 0 because of there's some maintenance, some cache memory behind the scene. But technically, last time I showed you 13, not actually not here. I'm so sorry. This one, 6 again. So that the maintain caches also they're very quick, 6 again. But technically here on an average is 6 and above. And last time without index, it was 3 and 4 millisecond. Okay, so what I'm talking about. Okay, so guys, this is one very important two things to keep in mind. Uh, understand one thing. Right now, we have here ages. Some age is 21, some is 25, then 25, then 26, and 46, and 61, 60, 87. Okay. So because we already created index and we already arrange as in sorting order, and everybody is mapping or referencing to their main IDs. Okay. If you search that age is about 20 and by chance everyone is 20, it means all the value match because everyone is about 20, everyone is matched. So it means because we are doing index scanning, what is index scanning do for you? They always come to this table. This is called index table. They always come to this table. They look, does this match? Yes. What is ID? This one. They go here and retrieve. Does this match? Yes. What is ID? They go and retrieve. So technically, because everything is matched, so all the ID will come up. Okay. But here it is unwanted extra time, guys, we are consuming to first look in this table. Look for the ID and find the document. Look again this number, look for the ID. Technically, this part extra come. Okay. Because we have to search in all the document by chance. Okay. So if you use, because this particular age, this particular I can say the filter that you have put here, by chance this filter look for entire data. So if you look for entire data, rather than you go via index table, if you can go directly, it will be faster. That's what is done here. Because you look for entire data, because my criteria is something like this. Okay, so if you go by indexing, so it is something like this. If we give you a book of 1,000 pages and say you to read the entire book and all the document. So better way would be just go page by page, right? But if you just go and back in the book, look for first topic, get the page number and number, then go that page and read it. Technically, you have to read all the topics, right? But just looking, or it's called lookup and index column, and then go back. So that lookup, then go back, referencing take extra time. Okay, so I believe that you understand what I'm trying to explain here is, if you have a criteria and if you think this is a very common criteria that you have, whatever filters your users are using or analytics guys are using, they are mainly writing a criteria or filter or searching where almost 80%, 90%, 100% document they are filtering and searching. Don't create index there. So index doesn't mean, guys, they always improve the performance. In those cases, it will impact your performance, because um, extra things you have to do, right? Like here, we have to go first search in this table, see the number and go the ID. It takes extra time. So there is not good practice to create an index. Okay, so there's a one thing, guys. One thing I want to explain you here. Okay, so that's all. So very interesting. This is very important point to notice. So in this case, right, without index will help you more in this particular kind of examples. If I remove the index and now if I search, okay, this will without index, it is a fast. They're doing full scanning and they are comparatively faster. Comparatively faster. Just in 3 seconds, around 4-5 milliseconds, they search for you. So keep this in mind when to create index and when when not to create index, and which key we use to create the index. Get the index. If you search for name or phone number, address, it won't help you much. Okay, but if you criteria on searching in about ages or database age, if these are the mainly create criteria, then create the index for this guy. Okay, so that this is about index, or we can create a compound index also. If you think, mostly we have to search not only in the age, we have to write one more query here. There's, let's say, it's called gender. Let's say gender would be male or female. So in find, I am using two filtering. I'm looking for all the age that is about 20. Let me use 60. And gender male. So if you see, guys, here, out of 5,000, on this month's record come up. Okay, guys, and you, when you write, guys, by chance this format, I want to look for this one, comma this one. So if there's a comma here, it is by default nature is and. So if you guys see here, they automatically put one function called and means if this and this match, then only result come up. So by default they add and here. Okay. So out of 5,000, 610 result come up. Because I don't have an index here, there's no key examine from the index table, right? They do full scan. Full scan. Okay, but but if you think this is the very very this kind of query is very common. We every day, every second, we have to do this query again and again and again. So you can create index based on these two key together. So it is something like this. It's something like this. We go and retrieve all the age, okay, and arrange the age in the order. There's one sorting order. Okay, and with the order, we also add one more thing, their respective age. This, let's say this is male, this female, this is male, female, female, male, female. Something like this. So my index table, two data come here. Okay, so you arrange your data in sorting. Now it is you decide you want to sort with respect to age or with respect to gender. First means which will come first. If you think, guys, mainly you are looking for male or female more, this kind of queries. Okay, so you can sort with respect to male also. But right now, guys, let's say our main plan is to search for ages, or I'm looking for anybody who is above 60, and then male, and this then what I'm doing, I'm creating this particular kind of, you can think, a string. Okay, where first age come up, then gender come up. So now technically it's very simple. If you're looking for all everyone who age is above 60 and they are male, So we know, guys, because we data is arranged with age. So above this we have no 60. After this we have 60. Two results come up. So we only look only in two results. Now we now go to this second column here, and because we're looking for male, we found this is male, this is not male. So one result we found or we examined and we written this value, because this is again linked with the ID. Something like that. Okay. So so technically if you put in the index table two things and more than two things, okay, uh, so that we don't have to search those things in the actual main document, this table will help me. Okay, does we have this criteria or not, we have anyone who have this age and this gender or not. Gender or not. Okay, so this kind of guys indexing is known as compound indexing. How can you do? Again, pretty simple. Right now in my current data, get index. I don't have any index created by us. So I'm going to create again one more index. Okay. And here my criteria is same. I'm looking for a DOB dot age and arranging the age in ascending order. Ascending order. And I'm going to add one more criteria here. I also want to store my gender information in my index. Again, gender also I'm arranging in the in the sorting order, or maybe in descending order. You get for descending, you can do -1. So here, male and female means be alphabetically information this two. That's all. So one more index they created. We see here this index they create two key. They store in the index tab. That's okay. This concept is called compound index. Okay, why I do this? Because we know my team normally looking for uh, searching. These are two criteria mainly they use, not always but mostly they use. So accordingly we plan to have this indexing. Now if I search this again and check my query analysis, so what you find, you found that that total this much document they examined and this much written. But guys, here they check more. Why? Because above 60, they find a lot of number, and some of the number might be female. So they search some extra, but obviously less than 5,000. So they they give me that result. Okay, let me run one more time. So just in 1 millisecond. First time, guys, normally they take some extra time, but if you run one more time in just in 1 millisecond, last time it was maybe 3 or 4 millisecond, but just in 1 millisecond, they give me entire 6110 result because they have done index scanning, and the way I've searched these key I already have in my index. This is the index name we had created, and this is a key pattern we put in our index name. So we search here, this index name they have created for us. Okay, so guys, there's a lot of information about indexing we have discussed and how to set up the indexes and all things we have discussed over here. So this is one of the topic, guys, I want to discuss with you. Okay, now let me go to the next topic. Again, very important topic. Maybe come into the advanced part, and I believe this topic is might not be there in the agenda or workshop, but as per your requirement demand come up, and again based on the real use case also, I thought to take this topic, but very powerful and very important topic, this one. Yes, can you hold for a second, please? So yeah, so let's discuss with next topic. Very important topic. uh, so what's the idea, what exactly we are going to do in this topic? Okay, so um, let me think in this way. 1 minute. If I search in this document, let me go for find one. Okay, in this document, guys, if you see, if you see, if you talk about the gender, so the gender in this document is male. Okay, and if you see, this gender is belong to one of the state. So location is one main key, then sub key, Yukon something. So this is the state of this gender. Okay, but if you see, guys, you have more 5,000 record. Okay, and in either in the record, gender is male or gender is female. But maybe I might have 10 male from this state, 5 female from this state, other male from different state, other female from different state. So what I'm looking for, I would like to count. I want to count that from this state. Okay, what is the total male or female? Okay, that would be my requirement. So if I a little bit more elaborate this point, so if I search for find, okay, and if I hit enter, well, let me print pretty paint. So if you see, guys, here, this particular guy is belongs to state Northern Territory, and this is female. So let's say my requirement is I wanted to count total female. It's so simple. I can search for female and count it. It's not big deal. Or if I want to count the total location where state is Northern Territory, if I count those total state, again I can search in the find and count it. Again with the count function, not big deal. But here my requirement is very different. I want to count in such a way from from this state total number of female. And now if you go above, we have one more, might be new state come up. In this state, total number of female. This is one, right? But we have more record from this state. Okay, for example, let me take one more example here. In this particular state is a new state. This is female, but maybe male come up. So I don't want to count male. Only when a female come up, okay, I want to count it. So per state, for example, anybody from India, obviously most of the guys made from India. So we have one state called Rajasthan, one is Maharashtra, one is Gujarat, right? So I want to count. This is a 500 record of India. So I want to count. I have to first filter all the female. Okay, then I want to check out of this, let's say 2,000 record come up. So out of 2,000, how many female from Rajasthan? Let's say 100. From Maharashtra, let's say 200. From Gujarat, let's say 250. So that I want it. And technically, guys, in the database world, those who know databases, this kind of concept is known as aggregation. Okay, so I want to aggregate my result. Aggregation, and this is so powerful topic and so important topic. Okay, almost in all the database we have those keyword and the concept, but it is very commonly used in MongoDB a lot. Okay, so MongoDB has created a separate framework for aggregation. This is called aggregation framework. Okay, and in this framework, guys, what I want to do, they have a concept called pipeline. So what I mean by pipeline, I will explain you in a minute. So they say whatever you want to do step by step. Do first thing, then second thing, then third thing, Okay, step by step, and by chance they give the name of the step is called stage. So run first stage, second stage, third stage, one by one. So technically this is called pipeline. Create a pipeline for that. What I mean by this, in a minute I will explain you what I mean by pipeline and this. But this is the term they use in the MongoDB. So it's very much advanced topic, and lots of uh, things is there in the MongoDB. So if you search for MongoDB and in the software in some of the tool, or maybe if you go to document, okay, or maybe very quickly go and search for MongoDB aggregation pipeline. Okay, so if you go to this particular topic, so they have lots of functions available through which we can get aggregation pipeline. Okay, so there are a lot of keywords they have through which we can do. So what I mean by the aggregation pipeline, okay, so they have a lot of functions like match function, sort keyword, group keyword. We'll connect these guys together and to create a pipeline. What I mean by this, in a minute we'll discuss, but a lot of things guys you can find from this particular document. But let me explain you what meaning of the pipeline. Okay, so let's say, but first you should be very clear about your thought, what exactly you're looking for. Okay, if you're looking for in your entire 5,000 record or the document, your first requirement is you also only want to search on a gender, and where gender is female. So this is your main criteria. Okay, this is first requirement. After all the female data sorted, then what I want to retrieve all of the locations. Okay, and location I want to retrieve the state. Okay, so this is my second requirement. But see, at the same time, after I retrieve the state, I am not interested so much to check, okay, first female this state, second female this state. Rather than I'm interested 5,000 time, well, let's say 2,000 females we have, 2,000 time some output print, and I can see all their state. I'm not interested in this. I want to sum the state. So, for example, state is Rajasthan, total sum is 30, state is Maharashtra, total sum is 35, something like this. Okay, and then we might want to do, maybe we have 50 locations or 50 state here. So I want to arrange my state in sorting order, or maybe my requirement is maybe somebody has 500 females, somewhere we have 2 female or 5 females. So I want to arrange my output with the number of female. This goes sorting. Okay, so technically, depend upon the requirement, I just plan in this way what I want to do. I first find all the female, then retrieve the location, count it or sum it, then I sort it. So like this concept is called pipeline. Okay, what I did, I created a pipeline where this is my stage number 1. So this is stage 1. This part is my stage number 2. And this part, if you want, is stage number 3. Okay, so obviously there's no meaning of sorting without the total count per stage by female per state wise. And there is no meaning to count the state before you filter or search. Okay, why? Because maybe we have gender male also. I don't want to count male. So I have to first found female, then output come up. So technically, if you talk about stage 1, this stage 1 give you the output, and this output I take inside stage 2. And what output they give? They only give me output of female. And this stage will retrieve, work only on those output what stage 1 give to me, There they found state. Where they find the state, okay, the state like for example Rajasthan, they count one, again Rajasthan come two, again Rajasthan come three, again Maharashtra come one, again Maharashtra come two, something like that. Okay, then then they this output will go to state 3. Okay, what output come up? State with the sum, location with the sum, and then we ask them to sort the order so we can conclude the thing very fast. Very fast. Okay, so this is the guys use case we have. And obviously in this use case I have to do step by step, and here guys step is known as stages, and all the stages connect together. It's called pipeline. So anybody who by chance know a Linux operating system or Unix, something like this we do in the Linux, we run the cat command, output come, and then we use a pipe symbol, then we send to grep command, for example, again output come, we send to next command. So this pipe symbol we use. So this is a kind of pipeline command very commonly we use and create in Linux. So this output go to this command, the output go to this command. How? With the help of pipeline. Something like this we are going to do here. But the final motto is, okay, I want to aggregate my result. So if you want to create the pipeline, so aggregation framework is the one who help you to create the pipeline, and that's what guys this document is talking about. Okay, we can create an aggregation pipeline. They are the framework. Using this we can do it. Do it. And for this guys, this framework has given us some function. Okay, so example, if you want to search for the female, okay, search for the female, where it is. Normally we know how to search. We can use a find function to search, so nothing very technical here. So I can search, I can ask find, can you help me that we are looking for a gender and the value of the gender is female. So we can use find function to search, they find for us, or maybe I can count here for checking how many females we have. So 65 total female we have. So searching is not a big deal, but if you want to create an aggregation pipeline, so aggregation pipeline has their own way of searching. So rather than we use a find function that we can use if you just only want to find, but if you want to create a pipeline, okay, where stage 1 you want to search something, and for this pipeline you want to use aggregation framework. So they have given their own personal keyword or the function. And for example, just for searching, they have keyword and function called $match. So if you search here, also guys, go to this document, you can find they have a function called match. So it's one of the keyword. It will help you to get one step, that they will go stage, and they will help you to filter the document. Filter means finding the document. Okay, so so let me show you guys how we can use this. Okay, so I'll again go to DB context, my collection. Instead of find, I will go for aggregate function. Aggregate function. And here, because I want to create a pipeline and I have multiple stages, stage 1, stage 2, stage 3, stage 10 maybe. So it would be list list of the of the stages. And because I have multiple lists, so this output inside will be very bigger. So what I'm doing, I'm not closing this guy. I can hit enter. So they give me a new line. Right? And you guys know in the MongoDB, everything is a document. And here I use a function called match. Okay. And here I'm searching for gender, and gender will be female. Okay. and then I close this square bracket and I close this parenthesis of the grid. So this is exactly like print function. The only difference is I'm using aggregate function or aggregate framework and asking this, you have your own personal match function. So match means go and filter wherever find gender equal to female in this current correction, just go and find for us. Go and find for us. Okay, and if you can hit enter, you can see the output come. Here, every gender is female. And obviously, if you can go for pretty, if they support pretty function, the proper output come up. Or if they support, I'll also try to count. So by chance, guys, this aggregate doesn't support count because they have their own inbuilt count function. But technically, if you try to see the output come up the way I want. So technically, stage number one is done based upon our requirement. Okay, we want to aggregate the female per state wise. I want to count. So one part we have done according to plan. The next part is I have to add one more stage where I want to do a main thing. Okay, what a main thing? I want to retrieve the location and want to summon. So how we can do? So for this, guys, this query will become a little bigger. So I'll open my notepad. I'll type here first, and I'll copy paste there. So let me copy this code. Let me type. Guys, can you hold for a second, please? So let me properly format. So this is one of my stage. Now let me add one more stage here with curly braces. So this is stage one, this stage two. Maybe you can add more stage three, or because there's a multiple stage, and because we are into the list, so obviously you have to put comma here to separate these guys. Comma. And now I'm not going to add third one right now. Only second stage I want to add. We don't have to write comma in the last. It's a normal JSON document. And here, what I'm looking for, I want to retrieve the state. For my state, I want to retrieve the location. And location, I want to retrieve state. So, guys, if you see the output, you will see already, the location dot state I am looking for. Okay, that's what I have written here. I'm looking for this particular data. Okay, and because, guys, you want to aggregate the result, so for this, you have to for this you have to group the thing. Okay, group the thing means, for example, let's say you find the state you can't maybe. Okay, so you just retrieve this when once, then one more time come up, then one more time come up. So technically this concept is called group. So normally in the database world, it's called group by also this concept. And for this, guys, if you see in the framework, okay, we have a group by a function. Okay, so this function we use to find the document in each group. So that's what I'm going to write here. So my main function, I have to start curly brace again, one, close one, and here I'm using the main function called group. So this is the one who helped me to retrieve this information and try to create a group. Try to create a group. Okay, so let's see what happened till here. Technically, this query is not complete, but let's check what come up if you run this query. So they say got this. format. Copy, copy, and run. So they say error. Okay, it's always good to see the error, and they say field state must be accumulator object. Okay, so what I mean by this line. So technically here they are talking about they're talking about I don't know how to accumulate the object. Means you say you want to group this state. So how you want to group? Okay, you want to find the average, or you want to count, you want to sum. For example, this may be not the state, this may be your attendance, or this may be your salary. Okay, so I'm looking for your name. Let's say I'm looking for your name here. Name is Vimal, and wherever Vimal come up in the entire data, where I have hundreds of Vimal document per month basis, and every month I have a salary. So I want to retrieve the salary of the Vimal, and then I want to sum it. Okay, so that's called accumulation. Or I'm looking for same thing, looking for a state. So I want to count it, the total state. And how you count? If a state come once, counting one, again same state come, counting two, counting three. So something like that. So here they're talking about, you say you are looking for the state, but I don't know how to accumulate this. Means tell me your aggregation function. You want to count, some average, what you want to do here. Okay, so that's what we have to write here. And how the same group function. Okay, it take actually two two argument. Okay, one is how you want to accumulate, and second one is oh. So first thing, which field you want to collect, and second thing is they are looking for they're looking for the what, how you want to aggregate, sum and count. So we have a sum as a function, count as a function. So we go to this document and we search here, you will find they have a function called sum. Some their function called called count. Search in the document, somewhere you'll find, or maybe here you'll go and search and find. Okay, so sum is a function, so I want to sum it. The sum is a one special function here, and what sum will do, here you can tell whenever this record match I want to start with someone. Technically it's called like count. When this state again match, so again add one, again match, add one. Same state. Okay, like normally in the programming world we do something like this. Something like this in the programming world, we start with x plus equals to 1. So every time you run this loop, value of x will increase. So something like this will do for you. Every time same state match, they keep on counting those state. So that's how it works. So group is a function. Group start from here and here, and group will require two things: which field you want to search, and what aggregation you want to do, count, sum, average. So accordingly they have the function available. Okay, that's all. So let me run this code and see this is right or we have to do something more. So again guys, we have some error come up. Why this error come up? Because this is some extra curly braces we have here, and try to find does we have. So technically this curly will start here. Okay, and this close here. Right, this start here, this close here, this start here, and actually we have to close here. Okay, so this one is small thing, nothing very technical. Copy. Again we have this error. uh, why this? Why? One minute. So this curly braces start, close, done. Let me write here. This start here, this close here, this start here, this close here. Everything look good. Even though guys we have the error. Why we have this error? Because it is not issue of actually of your MongoDB. It is a syntax of JSON. Technically, whenever you create any curly braces in the JSON, curly braces is like a dictionary, like a hashes, like a map. You have to give key and value pair. So technically, in this curly braces, we have given two values. This is one of the value. This is also one of the value. We can't directly give the value. We have to give some name also, key name also. So we have to give some key name, maybe like X colon something. We have to give this key name Y colon. You can give any name, there will be a choice, but this is a syntax we have to follow. Okay, because this JSON document, and what you write between the curly braces, even though guys here, this is also curly braces. So in this curly brace, this is the entire value, and this is the key. Okay, so that's the only challenge I believe these guys are getting. So you can give any name, whatever you feel like, but I'm giving a name X and Y. Okay, now if I run this, copy, paste. Now they tell you one more small thing: X must be an accumulator object. Technically, here they're talking about. They say what a key you use here. This key should available in your document. Okay, and this key is the one who will differentiate the document. Who is saying go functions? If we read the go function, they'll talk about. And you guys know there's one key in the document that differentiates document is underscore. So we use the underscore ID here. So we can differentiate, and every document we retrieve their state and then sum it. So there's one more thing we have to add here. Copy. Now, guys, this output come up. Now there's no error, and this output come up, and they say the total state is 2565. Then and this output, guys, is exactly equals to this output. And you know, this is not actually I wanted. Technically, this command also have done the same thing. What they done? They search all the female and count. Here also they search all the female count. But this is not actually I want. I wanted. My requirement is a little bit different. My requirement is I want to count total female. That is my requirement. But I want to count per state by. I want to retrieve state 1. Let's say Rajasthan count 1. Again Maharashtra come count 1. Again Maharashtra come count 2. Again Rajasthan come count 2. Count 3. So that's what I want to count. Obviously total female will this one only, but I want to print my result per state wise count. Okay, so what they have done here, they retrieve first state and add 1. This is second state, add 1. The third state, add 1. And obviously we are looking for female, so obviously same count will come. But technically what you have to see here, no, I am not looking to count in total state. I am looking to retrieve first state. So technically, you know what, here I am giving the reference of my state. And if you want to give the reference, there's an option called dollar. Okay, so dollar means retrieve my state name. Let's say Rajasthan is one of the state in India, Rajasthan, and keep this name somewhere in your mind in the memory and give the value 1. Again Rajasthan come up, just go and check in the memory if Rajasthan is there. Yes, because last value was 1, make it 2, then 3. Again new state come, let's say Gujarat come up, again one of the state in India, retrieve the value in memory with 1. Again Gujarat come up because we are giving the reference, means we are asking wherever you keep this information in your memory while running this code, keep on increasing the count. Okay, so guys, here we have to use dollar to achieve this. Okay. Now, when I run this query, this time I believe what exactly I'm looking for is comma. And this is exactly the thing I am looking for. Now, very clear, we have one state called Northern Territories. And here why? Because why I used here is some 60. Because we are looking for female now, because it means they filter female, it means in this area, the total female is 16. In Flevoland, total female is 10. In Vermont, total female is 4. So now this is the actual output I'm looking for. That this is called aggregation. And we have created two stages and get one pipeline work together to give me this output. Okay, or maybe you can give a better name for this y, because y print here. Better name for this y. So maybe I can say total female. Because we know we are looking for female. Let me run this query. Now the total female is in income. And that's one thing, guys, the output of this command is also a document. See here is one document is a collection. Okay, and because they are document, so we can pass this document to the next stage. So technically, if you run this, they also print document. Output of this document go to this document or this stage, and output of this document is this one. Output of this stage is this one, I can say. So we can pass this to the third stage of the pipeline. And what I want to do with the third stage, I want to sort this data based on total female. And guys, understand one thing, in this document on the fly we create our own key. This key we have created. Now in the next pipeline I can use this key and say whenever you find total female as a key, take this and help me to sort. How? So we can do and create one more pipeline. Again, hit enter. The second stage, so I can put comma here, curly brace start, curly brace close, and say I'm looking for sorting is one of the key they have. And how you want to do sorting? So what the output of this one come up, and guys, this line give me this output, and here they give me two keys. One is ID, state, or total female. So how you want to sort? You want to sort with based on state or based on total female. So I want to sort based on total female. Curly brace start, close, total female. So my sorting order with based on total female. You want to do ascending and descending. So guys, very simple reason. When you sort anything, if you put 1, they will do ascending order. If you put -1, they will do descending order. Let me go for 1. Okay, and this one thing, guys, my contact don't have any key with the remote total. My second state created this key on the fly form, and what output of this stage will go to this one. So what output of this stage, for example, if you want to do some sorting on the location, on the age, you can't do, because this output doesn't contain any age or location. Okay, so third stage will only helpful what we want to do, but they will do only operation based on the output of the second step. It's like a pipeline. It's the same thing, guys. In the Linux command also, you do first command, output go to second command output go to third command. But in third command, you can only do the things what output you get from the second command and vice versa. Okay, so that's what I want to do here. So let me run this query here. So in this aggregation, we have 3 stages, everybody connect to each other. So I can say it is a pipeline. So if I enter, now you can see they arrange the data in the sorting order. Technically, they printed 111. Why they printed 1 everywhere? 1 minute. Let me use -1. Yeah. I don't know why 1 is not working. Maybe 0. I think only this here. Maybe guys, you go and check the document sorting. -1 is working properly the way I want it. Because here, automate your data arrange in sorting order. Okay, in descending. Bigger one, small, 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 small. So we can say this is one of the medieval land. We have that they had maximum female, then Austrian capital territory, they have less female and less. Okay, so this is the descending order they arrange this data for you. So it's long topic, powerful topic, very important topic, and very beautifully, guys, they actually help us to arrange this. Otherwise, if we go to SQL world, there also we can do the same thing. But because of this framework or this because of the aggregation function, okay, now things become might not be so much simple right now you're looking, because this is my first time you're touching this queries here. But now because everything is document, so all the thing you know about document or JSON put arrange one by one in a list, and what you want to achieve here. After, guys, you also get this output, you want to do some more thing. Let's say I only want to retrieve that names, or only want to retrieve the state. You can write one more query here, one more function, they will retrieve the particular thing. Okay, so go to the document, what I document I opened for you, and you can find some more functions. But these are the very commonly important functions that I pick here: match, group, and sort. Okay, I'll share this code to you. So I'm going to test this code as is. You can test also. Okay, so very much important. So guys, this is all about aggregation framework. Now I given the idea, almost all the core logic of this. Okay, and based on this idea, you can do it. I want to tell you one small homework, and this homework, if anybody want to do, you can do. No issues. But this homework, guys, is mainly for the Earth learner. So anyone who is from here, from the Earth learner or Earth program. So what you have to do, you have to use the same aggregation framework and something like of this logic, guys, I explain you in our Hadoop classes, where I explain you map reduce, where you guys think it is something like mapper, this look like a reducer. Okay, so try to do a map reduce kind of concept here. And guys, here if you see, guys, they have a concept of map reduce. So in the aggregation framework, guys, they have a concept of map reduce. Maybe somewhere you might see here. I don't know, somewhere. Yeah. Here it is, map reduce. Okay. So in the MongoDB, if you want to create a map reduced example with this kind of pipeline, you can do it. If other attendees want to also do, they can do it, take as a homework. Okay, but I this compulsory task for all the Earth learner, try to use this. They also example also, just try to go through example, right, based upon the concept. I think this will help you, or you can create your own example to do it. Okay, do it. So this is one homework from my side to everyone, but is for the Earth learner, it is a compulsory homework. Use MongoDB, use aggregation framework to create some example of map reduce. Very powerful example. You will see it will be created for you. So that's all, guys, for right now. Let's go for break. One more or two more small topic we have left to discuss and to be completed. Any queries you have till now, you guys can ask before